So we just got these 4-piece sets of Machinist squares back in stock. They've been out of stock for many months. So I thought I'd take a few minutes and talk about them. First of all, I want to talk about, do I think that the average person, average woodworker, DIYer needs these in their shop? I'll talk about some of the features of the squares. I'll talk about some of the common uses. Then I'll talk about how do you know if a Machinist square is really square, or if it's what the manufacturer claims it is. So first thing is, do I feel like the average woodworker or DIYer or garage shop person needs these in their arsenal of measuring tools? Absolutely. These squares are really not that expensive. I mean, you get the 4 squares here for 35 bucks. I mean, you're not out a lot of money, but you have a square that is very useful. This square is guaranteed to be square from the tip to the end here to 1/1000th of an inch. So you don't really need much more accuracy than that. So some of the features, besides these being guaranteed square, they are made out of tool steel and they're lapped, so they're pretty smooth. They have a base here and that has a slot cut in the base. This blade is then placed in there. This blade is then held in place with 2 taper pins, so this thing's not going to move. It's got a little slot here in the corner as a relief for, if you're trying to get into a corner. The base is big enough so the square can stand up on its end. So if you want to use it hands-free, you can do that. It also, they come in this cool set of 6-inch, 4-inch, 3-inch, and 2-inch. So every size you need, you have. And then they come in this wonderful case so you can keep them stored and keep it protected so they're not banging around in your drawer. And it also protects against rust. So what do I use them for? So some people use these for like routine shop layout. I really don't. I usually like my double square to do my routine layout of parts, like when I'm trying to lay out like holes to drill or mortises or tenons or whatever. So I don't use these for that. I use my double square and I also use my combination square for routine shop layout. But when it comes to setting up machines, like I need to set up a crosscut sled and I need it to be square and I want to check my parts, I will use these to check to make sure my parts are square, make sure my machine is set up really well. I also use these squares, probably my most common use, is I'll use them to set up like the fence on my joiner or my table saw to make sure the table saw blade's 90 degrees. I also use it on the bandsaw to make sure that the table is 90 degrees to the blade. Also, when I buy a new measuring device, like a new square, if I were to buy a new double square, the first thing I would do is check it, make sure it's square. If it's not, send it back. The other nice thing about having the set here is you can actually check each square against itself. So you can put one square against another one and see this one, they're perfectly square. So how do you know if a square is really square? Well, the first thing you need to be aware of is a manufacturer needs to tell you how square the square is. Just saying that it's guaranteed square doesn't tell me anything. I need you to tell me how square it is, like how out of square it can be before it falls out of specification. So generally they'll tell you that, like how much the deviation is of the blade over the length of the blade. And usually they'll do that in inches, 1/1000th of an inch. Some of them do it in metric, like 0.1 millimeters. Some people do it in microns. We sell some squares that are actually guaranteed within a micron or so many microns. A micron is actually a 1/1,000,000th of a meter. And then some people will play a dirty trick and tell you that it's accurate to a certain degree, which I'll do a separate post on that to show you how that can be really deceptive. So when you get your square, how do you know it's square? Well, the first thing you can do is you can actually take one of the squares and set it against itself and see if it's square. Now, just remember that just because this square says it's accurate to within 1/1000th, that means that it can lean to the left 1/1000th or the right 1/1000th and still be within spec. So let's say that this blade is out of spec to the left 1/1000th, and then this blade is out of spec 1/1000th to the right. So you might see a little gap there. Another thing that I think is very deceiving is people think that just because they can see a gap that it's not square. Well, the fact of the matter is that you can see a whole lot of light if you hold 2 squares up to the noonday sun and there's a 1/1000th of an inch gap. So just because there's a gap doesn't mean that the squares are out of spec. The only way to really check squareness is to have a reference square and to use what we call a feeler gauge. You can actually then place this gauge between the 2 devices and you can see what the gap is. So this blade here is 1.5 thick. This is 2 thousandths thick. So if I had 2 squares next to each other and I wanted to make sure they're within spec, I'd hold them up here. And if I could get a 2 thousandth of an inch feeler gauge between those 2 blades, then I could say that it's out of specification. Other than that, I would say they're pretty good. Another thing about square that I think is important is that some people think they need a square that's accurate to a 1/10 of a 1,000th of an inch, which in a wood shop, it's just too much. When you buy squares, the more accurate they are, the price goes up. And so when you get a square that's accurate to a 1/10 of a 1,000th of an inch, you're going to pay $200 for a square this size. And it's really not going to impact your work that much at all because you're not working to that level of accuracy in a wood shop. So there's a law of diminishing returns. You can spend a whole lot more money, but it really doesn't impact your work that much. So I feel like a 1,000th of an inch over the length of a 6-inch blade is sufficient accuracy for any shop. I want to talk about how you can determine accuracy in a square when the manufacturer states their specification in degrees. So one time I had a manufacturer tell me that he had a square that was accurate to 1/10 of a degree. So that sounded pretty good, but I didn't know, so I had to figure that out on my own. So here's how I would go about calculating that. So that means that the end of this blade can deviate 1/10 of the degree left or 1/10 of the degree right. So when I draw that out, I want to draw it out as a triangle. So this is the deviation. And then here's the starting point. So this down here would be 1/10 of a degree, 0.1 degrees. This length here is 6 inches, okay? And then this is 90 degrees. So when you remember trigonometry, if you paid attention in high school, you know that if you have a triangle and you know any three of the variables, which a triangle has 3 side lengths and 3 angles. If you know any 3 of those and you plug them into an equation, you can determine the other 3. So I forgot all the equations, but I went online and found this trigonometry calculator, and I actually plugged in this angle here at 0.1 degrees and this length here on the side as 6 inches. And it came out that this length here, A, or the deviation, was 10 thousandths of an inch. So this square can be plus or minus 0.01 10 thousandths of an inch, which is terrible. So this square that sounded so good at 0.1 degrees really wasn't that square. So be wary when manufacturers tell you accuracy of squares in degrees. Pick them up at ttools.com.